Today we're going to take a look at the first portion of our modeling unit, which is input and output of functions. Pretty basic. The goal is for you to be able to recognize when looking at a function what is the input, what is the output, what are the variables and the units associated with both the input and the output. And then the other thing you're going to have to decide is the rule that we're looking at a function or not. And as a review from Algebra 2 and Math Analysis, a function is a situation where every input has its unique output. So that means if you have an input of 2, it can only have one unique output. You couldn't have an input of 2 with an output of 4 and then another data set that has an input of 2 with an output of 5. So every input must have its own unique output. So let's take a look at a couple modeling examples and decide what the input and output is and if it's representing a function. So in problem 1, it's talking about the weight of a letter and how much is it going to cost you to mail that letter. Obviously, the heavier the letter, the more you're going to spend. So there's a function that represents the cost depending on the weight. So we need to decide what is our input and what is our output. Whoops. Okay, so we have our input and our output. So the cost is dependent upon how much the letter weighs. So our input is going to be our weight. And our output is going to be the cost, or the rate, we'll call it rate. Okay, so the next part is what is the variable that's used in this problem to represent it. You can see here the function is represented by RW. W represents the weight, R represents the output of the rate. So weight, our input, is represented by the variable W, and our output of rate is represented by a capital R. And then the next thing it's asking for, well, what are the units? Well, in the problem when you read it, it says that the letter is measured in ounces. And the cost is measured in cents. So you have to be careful with that. You might think it would be dollars, but it's cents. Okay? And then the final part of this is determine whether the rule is a function. So will every possible input, a weight, have a different output? Could you weigh a 2-ounce letter and there be 2 different costs? No. A 2-ounce letter is going to have one fee associated with it. So yes, this is a function. Okay, so let's take another look at number 2. So number 2 is how well you did on a test depending on how many hours you studied the week before. So your score is dependent upon how much time you put into the test. So our input will be our time. How much time did you actually sit down and study for the exam? And your output is going to be your score. Okay, looking at the function notation provided in the problem, you can see that T is going to be used to represent time, and your output score is going to be capital G. Okay, and then our units, it's dependent upon hours, and then the units of your output is your points. It doesn't say percentage, it says points out of 100, so points. Right? And then you have to decide, is this a function, is it not a function? So you could, depending on how many hours you studied, depending on who the person is, one person could study for 2 hours and earn a 90, the other person could study for 2 hours and only earn a 70. So this actually is not a function. All right, let's take a look at another example here. Okay, so the amount of an investment account in dollars after 2 years, assuming that no deposits or withdrawals are made after that year. So in this situation, you are depositing an amount of money into an equation, and then the output is how much money you have afterwards. So your input is the deposit. oops, I'm sorry, the input is the time, and then after how much time passes, that's how much money is in your account. I apologize. So input is your time, and output is the amount of money in your account. So hopefully the longer it sits there, the more it makes. Okay, we're going to use the variable t to represent time and b to represent amount. And this problem tells you that time is in years and your amount is in dollars. Okay. So the other thing we need to take a look at before we move on is looking at a set of data and just deciding, is it a function, is it not a function? So does every input have its own output? 16 to 19, there's no other input that is 16 to 19. There's no other input that's 20 to 24. So all of these inputs are unique, which means they're all only going to have one output. So yes, this chart, which represents the age of a person and the percent of people with a flex time schedule at work, is a function. Okay. Now this one is a table that represents your military rank and then your base pay in 1997. So every input, there's no repeats here in your inputs. They're all independent. So that means there can't be two different amounts that a captain makes because we only have one input of a captain. So this is also represented by a function. Okay, so after you watch this video, you should be able to complete the input-output homework practice worksheet. If you have any questions, bring them into class tomorrow. All right, have a good night.